Hi everyone, this is Arvind from MindMajix, and today I welcome you all to this amazing video on SRE AWS interview questions. So guys, you must be knowing that the cloud is an integral part of any SRE role. So in this particular video, we have heavily focused towards AWS. Like there are many other platforms as well for cloud, such as we have Microsoft Azure and Google Platform. But in this particular video, we will be focused entirely on AWS. Okay, so in this particular video, we will be covering roughly around 30 questions. And these 30 questions, like you all know, are divided into three categories. The first 10 questions are meant for the beginners, or they are the very basic questions. And then we have the next set of questions, which is meant for the intermediate candidates, like those people who have at least 2 to 3 years of experience working with SRE and AWS. And then finally, we will be covering the last 10 questions of this video. And these are the questions that are meant for the advanced people, like those people who have at least 4 to 5 years of experience working in the space of SRE and AWS. So I hope the agenda is pretty much clear. And before moving ahead, I want you guys to subscribe to MindMajix's YouTube channel and also hit that bell icon so that you never miss an update from us. So without any further delay, let's get started with the first question. So the first question is a very basic question, and this is pretty obvious. So the question says, what is SRE or Site Reliability Engineering in the context of AWS? So SRE or Site Reliability Engineering in AWS is the practice of applying software engineering principles to infrastructure and operations problem, and that too in the cloud. So it focuses mainly on automation, monitoring, scalability, and reliability of the AWS-based systems. So the key word over here is the AWS-based systems. So in AWS, the SREs use services like CloudWatch for monitoring, EC2 for compute, and auto scaling for load handling. So the main goal over here is to ensure that the availability and performance and resilience of the cloud workloads. For example, an SRE might write an automation script in the Python to scale the EC2 instances dynamically based on CloudWatch alarms. So in short, SREs blend development skills with operations to keep the AWS systems running efficiently. Now let's move to the next question. So the next question says, what are the services that are commonly used by SREs? So the AWS SRE typically works with the services across compute, storage, networking, and monitoring categories. So common compute services include EC2, ECS, and Lambda for running the workloads. So for monitoring and alerting, we have CloudWatch, X-Ray, and CloudTrail. And SREs also work with Route 53 for DNS, ELB or Elastic Load Balancer for load balancing, and S3 for storage. So in real world scenarios, SREs combine these services, for example, using CloudWatch metrics to trigger an auto scaling group to add EC2 instances when the traffic spikes. So if you have mastery of these services, this is very much important for effectively managing the uptime and the performance of the AWS-based systems. The next question is, explain the concept of SLI, SLO, and SLA in AWS. So SLI, which is nothing but service level indicator, these are the metrics that measure the performance of a service. For example, the latency of an API in AWS. Now, if you talk about SLO, so these are nothing but the service level objectives, and these are the target values or the ranges for these indicators, such as 99.9% uptime for a web application. And now if you talk about SLA, which is the service level agreement, so these are the contractual commitments to customers, often with penalties if targets aren't met. So in AWS, we have CloudWatch that can be used to measure the SLIs like the error rates or the request durations. So an SRE might set an SLO for an EC2 based API to respond in under 200 milliseconds for 99% of requests. So understanding these terms help the SREs to align the reliability with business expectations. The next question is, how do you monitor the AWS infrastructure? So monitoring AWS infrastructure starts with AWS CloudWatch, which collects the metrics, logs, and events from AWS services. So CloudWatch alarms can be set to trigger notifications when the thresholds are breached. So for example, when a CPU usage is going above 80% for more than 5 minutes. Apart from this, AWS X-Ray also helps to trace the requests through applications, and this makes it easier to find the performance bottlenecks. So for a complete picture, SREs often integrate AWS monitoring with external tools like Datadog, Prometheus, or Grafana. So in the real world, an SRE might monitor the Lambda invocation errors, identify a spike, and use the logs to trace the issue to a malformed API request. So continuous monitoring is the key to proactive incident detection. The next question is, what is an auto-scaling group and how does it help reliability? So an auto-scaling group or ASG in AWS automatically adjusts the number of EC2 instances based on the traffic or performance metrics. So this ensures that your application always has enough capacity to handle the load, but it doesn't waste money on the unused resources. So ASGs use the CloudWatch alarms to trigger their scaling policies. So for example, if the CPU usage stays above 70% for 5 minutes, ASG can add 2 more EC2 instances. So this elasticity improves the reliability by preventing the overload during peak traffic. So in SRE work, the ASGs are a core mechanism for meeting the SLOs during the demand fluctuations. The next question is, can you describe a real-time incident that you have handled in AWS? So guys, if you talk about this particular question, so this is purely a subjective questions. So the answers can change depending upon your projects or the experience that you carry in this particular field. So for answering this question, I'm taking an example. So let's say in a real world case, an e-commerce website experienced sudden 500 errors during a flash sale. So as the SRE on call, what you can do is you have checked the CloudWatch metrics and noticed the ELB target group had several unhealthy EC2 instances. So using the AWS Systems Manager, you have accessed the logs and found a memory leak in the application code. So for that, what you can do is you can restart the affected instances and roll out a hotfix using the code deploy. So finally, what you can do is you can update the auto-scaling health checks to remove the unhealthy instances faster. So the incident reinforced the value of automated health checks and proactive monitoring. The next question is, how do you ensure high availability for an AWS application? So high availability or HA in AWS is achieved by deploying the resources across multiple availability zones and sometimes multiple regions as well. So using services like Elastic Load Balancing, auto scaling, and Amazon RDS multi-AZ ensures failover capability. So for example, a web app might run in 3 availability zones with Route 53 health checks, redirecting the traffic if one zone goes down. So data can be replicated using S3 cross-region replication for disaster recovery. So an SRE also implements regular failovers drills to test the readiness. So the goal is to eliminate the single point of failure in the entire architecture. The next question is, what is AWS CloudFormation and how is it used by SREs? So guys, AWS CloudFormation is an infrastructure as a code or IAC service that lets you define and provision AWS resources using templates. So for SREs, it enables the consistent and repeatable deployments, reducing human error. So instead of manually creating EC2 instances or security groups, what you do is you define them in the YAML or JSON templates. So this helps during incident recovery, for example, spinning up an identical staging environment for debugging. So CloudFormation also integrates with CI/CD pipelines to automate the infrastructure changes. So by using the version controlled templates, SREs can roll back the infrastructure to a known good state quickly. The next question is, how do you handle AWS service limits during scaling? So AWS imposes service limits such as the maximum number of EC2 instances per region. So during scaling events, hitting these limits can cause outages. So as an SRE, I monitor the usage with AWS Trusted Advisor and set the alerts for resource thresholds. So if limits need to be increased, I open a service quota request in advance of expected traffic spikes. So in a real world case, we preemptively increased our EC2 limit before Black Friday sales, ensuring smooth scaling. So proactive quota management is essential for reliability in high demand periods. The next question is, what is AWS Trusted Advisor and why is it important for SREs? So AWS Trusted Advisor is a tool that provides recommendations for cost optimization, performance, security, and fault tolerance. So for SREs, it is pretty much valuable for spotting the misconfigurations, underutilized resources, and security gaps. For example, it can flag an S3 bucket that publicly accessible or an EC2 instance that is under provisioned. So in one instance, the trusted advisor alerted us to unused elastic IPs that were incurring costs unnecessarily. So regularly viewing the reports helps us to maintain the optimal AWS environments and avoid preventable incidents. So guys, with this, we have completed the beginner level questions, and now we will be covering the intermediate level of questions. So the next question over here is, this is a scenario based question wherein you have been presented with a scenario, and basically the interviewer here wants to understand what approach will you take to solve this problem. Okay, so the scenario is, let's say your RDS instance is experiencing a high CPU usage. So how do you troubleshoot this scenario? So you can answer this question by saying that, you can start by checking the CloudWatch metrics for CPU utilization, database connections, and query performance. So once this is done, what you can do is you can use the performance insights feature to identify the slow or expensive queries. So if the issue is query related, so what you can do is you can optimize the indexes or rewrite the queries. Apart from that, what you can also do is you can consider upgrading the instance size or using the read replicas to offload traffic. So if the CPU spikes are due to maintenance tasks, so you can reschedule them to off-peak hours. So always document the root cause and the fix for the future references. The next question is, how does AWS CloudWatch help SRE teams? So AWS CloudWatch is a monitoring and observability service that collects the logs, metrics, and events from AWS resources and applications. So SRE teams use CloudWatch to track the system performance, detect the anomalies, and set up automated alerts for incidents. So it integrates with AWS Lambda for automated remediation and with CloudWatch Synthetics for synthetic monitoring. So by visualizing the metrics in dashboards, SREs can quickly identify performance bottlenecks and take the corrective action. So this proactive approach reduces the downtime and improves the user experience. The next question is, like this question is based on the previous question, explain the difference between AWS CloudWatch and AWS CloudTrail. So as we already know, AWS CloudWatch is used for monitoring the metrics, logs, and setting alarms, whereas AWS CloudTrail records the API calls for auditing and compliance. For example, if the CPU usage spikes, the CloudWatch alerts can trigger an auto-scaling action. CloudTrail, on the other hand, would help you find out who initiated a specific EC2 instance termination. So in short, CloudWatch is about performance monitoring, whereas CloudTrail is about governance and auditing. Let's move to the next question, guys. And this question is again a scenario-based question. So let's say your EC2 instance is not reachable. So how do you troubleshoot this particular scenario? So over here, what you can do is firstly, check if the instance is running in the AWS console. Once that is checked, what you can do is you can verify whether the security group inbound rules for SSH, which runs on port 22, or RDP, which runs on port 3389, depending upon the operating system. Next, confirm that the network ACL settings and route tables in the VPC. So if everything is correct, check if the instance's CPU or memory is overutilized, possibly using the CloudWatch. Finally, try restarting the instance or checking the system logs from the EC2 console. The next question is, What is the role of infrastructure as code for SRE in AWS? So infrastructure as code or IAC allows the SREs to define, provision, and manage the AWS resources using code instead of manual configuration. So over here, we have tools like AWS CloudFormation and Terraform, and these tools make it easier to replicate the environments, enforce consistency, and roll back the changes. So IAC supports version control, making infrastructure changes auditable and reversible. It also speeds up incident recovery by allowing quick redeployment of affected system. So this automation reduces human error and improves the system reliability. The next question is, how do you monitor and optimize AWS costs in an SRE role? So an AWS SRE would regularly review the AWS Cost Explorer and create the budgets with the alerts for cost thresholds. So for this, what you can do is you would tag all the resources by environment like production, development, and testing, and owner for better visibility in AWS cost and usage reports. So implementing auto-scaling policies helps you to ensure that the unused resources are automatically decommissioned. So using saving plans and reserved instances for predictable workloads can reduce the costs significantly. Apart from that, what you can do is you can also set up the AWS Trusted Advisor to recommend right-sizing instances, eliminating unused volumes, and optimizing storage tiers. So in real time, CloudWatch metrics can show if the over-provisioned resources are causing unnecessary expenses. The next question is again a scenario-based question. So let's say you notice a sudden increase in latency for your application hosted on AWS. So how would you troubleshoot this scenario? So to answer this question, you can start by checking the CloudWatch metrics for CPU, memory, and the network I/O across all of the EC2 instances or container tasks. Next, what you can do is you can verify if there's a scaling lag in the auto-scaling group or ECS service, which might be causing the resource shortages. Apart from this, you can also check the health and latency metrics of the ELB to see if the issue is isolated to certain availability zones. So if the application depends on the RDS or DynamoDB, you would check the query performance and throttling rates. So for network level problems, AWS X-ray or VPC flow logs can help you identify the bottlenecks. Finally, you can implement short-term scaling or caching fixes while investigating the root cause to prevent the recurrence. The next question is, how do you implement disaster recovery in AWS? So disaster recovery involves replicating workloads and data across geographically separate AWS regions. So for critical workloads, you can set up active-active replication using the services like Amazon Aurora Global Database or S3 cross-region replication. So for cost efficiency, pilot light or warm standby strategies can be used where minimal infrastructure runs in the disaster recovery region until needed. So Route 53 can be configured with failover routing policies to redirect the users in case of a regional outage. Apart from this, you also have to ensure that IAC templates are stored in a versioned repository, allowing quick environment rebuilds. So regular DR drills are essential to validate that failover works as expected. The next question is, how would you set up centralized logging in AWS for observability? So centralized logging in AWS can be achieved using CloudWatch logs, AWS OpenSearch service, or third-party tools like Datadog. So you can configure applications and services to push the logs into a centralized log group. So logs would be tagged by service, environment, and application to make searching easier. Apart from this, you can also enable the metric filters to generate the alerts based on log patterns. And for long-term retention, logs can be exported to S3 and queried with Athena. So role-based access controls in IAM would ensure only authorized users can view the sensitive logs. The next question is, how would you approach scaling an RDS database for performance? So scaling RDS can be done vertically, like upgrading the instance type, or horizontally using read replicas for read-heavy workloads. So you can start by enabling the enhanced monitoring to identify the bottlenecks such as the CPU, memory, or IOPS usage. For write-heavy workloads, you can explore sharding or switch to Amazon Aurora for better scalability. For read-heavy workloads, read replicas can be created and integrated into the application's query logic. So index optimization and query tuning can significantly improve the performance without scaling the hardware. Finally, you can set up automated storage scaling to prevent the out-of-space errors. So guys, with this, we have covered the intermediate level of questions for SRE AWS. And now question number 21 onwards, till question number 30, we will be covering few of the advanced questions. So the next question is, how do you secure sensitive AWS credentials for automation scripts? So first and foremost, what you can do is you can avoid hard coding AWS credentials in scripts and instead use IAM roles with appropriate permissions. So for EC2 instances, you can assign an instance profile, and for Lambda, you can use an execution rule. So secrets manager or systems manager parameter store can securely store API keys, passwords, and tokens with encryption. So access to secrets would be logged and monitored via CloudTrail, and temporary credentials from AWS SREs can also be used for automation tasks. So regular IAM access reviews would ensure that there are no excessive permissions that exist. The next question is a scenario-based question. So let's say you get a PageDuty alerts for high error rates on an API gateway. So what will be your immediate response to this particular scenario? So you can first check the CloudWatch metrics for 4xx and 5xx errors to see if the issue is client side or server side. So if it is client side, for example, if it's 4xx, you can review the request patterns and possible rate limiting triggers. Whereas if it is server side, like 5xx, then you can check the integration backend, such as Lambdas, ECS, or HTTP endpoints for errors or latency. Apart from that, you can also look for recent deployments that might have introduced a bug. So if the root cause is load related, you can temporarily increase the throttling limits or scale the backend service. So finally, you can also document the incident in the post-mortem for future prevention. The next question is again a scenario-based question. So the scenario over here is, let's say your microservices application in EKS is experiencing intermittent failures. So how do you debug this situation? So to start, I would use the kubectl logs to inspect the application logs for error messages and use the CloudWatch container insights to monitor the CPU, memory, and network usage at the pod and the node level. I would also check for the pod restarts or containers going into the crash loop backoff to see if the failures are related to resource exhaustion or configuration errors. So if the logs don't show an obvious issues, so what you can do is you can use AWS X-ray or service mesh tracing to trace the requests and identify the bottlenecks or failing dependencies between services. Apart from that, you can also verify if there are DNS resolution issues within the cluster by testing the name resolution from inside the pods, as misconfigured core DNS can cause the intermittent service failures. So if the failures correlate with the traffic spikes, you can review and possibly adjust the horizontal pod autoscaler thresholds to ensure that the cluster scales quickly enough to handle the load. So it is also important to check the EKS events and Kubernetes health probes, such as liveness and readiness, to ensure that the pods are being managed correctly by the orchestrator. Finally, what you can do is you can perform a root cause analysis to determine if the issue is in the application code, cluster configuration, or AWS infrastructure and document the findings for future prevention. The next question is, how do you handle zero downtime database migrations in AWS? So to achieve zero downtime database migrations, you can start by creating blue-green deployment setup with two separate RDS instances. So one for the current production workload and the other one for the new version. So schema changes would be implemented in a backward compatible way so that both the old and the new applications can work with the database during the transition. So I would use the AWS Data Migration Service or the DMS to replicate the data continuously from the old database to the new one, ensuring the minimal lag. So before switching traffic, I would run the consistency checks to verify that both the versions are fully synchronized. So once validated, what you can do is you can update the application endpoints or Route 53 records to point to the new database. So the old database would be kept in standby for a rollback window in case the unexpected issue arises. Finally, you can monitor the CloudWatch metrics and application performance closely after the switchover to confirm that the migration was successful without impacting the end users. The next question is, how do you design a multi-region active-active architecture in AWS? So to design a multi-region active-active architecture, I would deploy the resources in at least two AWS regions with synchronous or near synchronous replication to keep the data consistent. So Amazon Route 53 can be configured to DNS-based failover, while the global accelerator helps distribute the traffic globally with low latency. So for data consistency, you can use the services like DynamoDB Global Tables or Aurora Global Database, which provide built-in cross-region replication. So both the regions should be capable of handling the 100% of the expected traffic in case one fails. So this setup ensures that high availability, resilience against the regional outages, and the seamless user experience even during failures. So the next question is, let's say there's a scenario. So you need to migrate a monolithic application to microservices in AWS. So what will be your approach to this particular scenario? So you can start by analyzing the existing monolith to identify the logical business domains that can be separated into independent services. So each service would be designed with its own database where possible and deployed on AWS compute options such as ECS, EKS, or Lambda, depending upon the scalability and the operational needs. So Amazon API Gateway would act as a central entry point, routing the incoming requests to the appropriate microservice while handling the authentication and throttling. So a shared observability layer with CloudWatch, X-ray, and log aggregation would be set up to track the performance, errors, and inter-service communication. So to minimize the downtime and the risk, I would follow the Strangler Fig pattern, migrating one functionality at a time from the monolith to the microservices while both run in parallel. So this allows the gradual replacement without disrupting the existing users. Apart from that, you can also implement the CI/CD pipelines or code pipeline or GitHub actions for automated deployments of new services. Finally, I would run the performance and integration tests at each migration step to ensure the stability and maintain the user confidence throughout the transition. The next question is, how do you implement chaos engineering in AWS? So to implement chaos engineering in AWS, I would start by defining the reliability goals and identifying the critical components of the system that need testing. So using AWS Fault Injection Simulator or FIS, I can create experiments that simulate the real-world failure scenarios such as EC2 instance terminations, increased network latency, API throttling, or even an entire availability zone outage. So these experiments are run in a controlled environment, ideally during off-peak hours or in a staging to avoid unintended customer impact. So during the test, I would monitor the system metrics and logs in CloudWatch, track distributed traces in X-ray, and observe how quickly the system detects and recovers from the fault. I would also validate whether the failover mechanisms such as auto-scaling or Route 53 health checks perform as expected. So the findings from these experiments would be documented to improve the architecture, automation, and incident response processes. So over the time, regularly running chaos experiments helps ensure the system consistently meets its SLOs and remains resilient under unexpected conditions. The next question is, let's say there's a scenario. So you have a latency in a global AWS app that varies by region. So how do you fix this scenario? So to address the regional latency differences, I would first analyze the CloudWatch metrics and use the tools like AWS SRE to pinpoint where the delays occur, whether in the network, application processing, or data retrieval. So implementing the AWS Global Accelerator would help route users to the nearest healthy endpoint using the AWS Global Network and thereby reducing the round trip time. So for static content such as images, scripts, and style sheets, I would enable Amazon CloudFront caching at the edge locations so that the content is delivered from the servers geographically close to the user. So for dynamic content, I would deploy the application stacks in multiple AWS regions, ensuring each region can serve the requests independently. So Amazon Route 53 latency based routing would then be used to direct traffic to the region with the lowest latency for that user. So if the application relies heavily on a database, I would implement Aurora Global Database or DynamoDB Global Tables for low latency data access worldwide. So finally, I would set up continuous monitoring to measure the latency improvements and quickly detect any performance bottlenecks. So guys, the next question is again a scenario-based question. So let's say in CloudFormation stack deployment is failing, and how do you troubleshoot this particular scenario? So when a CloudFormation stack deployment fails, the first step is to check the CloudFormation events tab to identify which specific resource caused the failure and what error message was returned. So I would then verify whether the IAM role used for deployment has all the necessary permissions to create, modify, or delete the resources in the stack. Next, I would validate the CloudFormation templates using the tools like cfnlint or the AWS CLI validate template command to catch the syntax errors or structural issues. So if the failure is due to a missing resource dependency or incorrect resource order, you would update the template to define the proper depends on relationships or references outputs correctly. So in case of repeated failures, I would roll back to a previous stable template version to restore the service while continuing to debug the issue. The next question is, how do you design an observability stack in AWS for a large microservices system? So for a large microservices systems in AWS, I would start by using the Amazon CloudWatch to collect metrics such as CPU usage, memory, latency, and error counts and set up CloudWatch alarms for thresholds that indicate potential issues. So AWS X-Ray would be integrated for distributed tracing so that I can visualize end-to-end request flows and identify the latency bottlenecks between the services. So for log storage and search, I would send an application and system logs to Amazon OpenSearch service, which was previously Elasticsearch, enabling fast filtering and analysis. So to ensure that the requests are traceable across different services, I would implement correlation IDs in the headers and propagate them through the entire request lifecycle. I would then create a custom CloudWatch dashboards showing the key KPIs like service health, P95 latency, and the error rates, and set up alerts via SNS or PagerDuty so that the on-call team gets notified in real time when an incident occurs. So guys, with this, we have come to the end of this session on SRE AWS interview questions. I hope you guys have enjoyed this session. If at all you have any doubts or queries related to this session, you can write them in the comment section and we will try to resolve them as soon as possible. So guys, thank you so much for being with us and I wish you all the very best for your upcoming SRE AWS interview.